We need to verify that the following points are the vertices of a rectangle. So let us begin. To begin with, we'll consider a quadrilateral A, B, C, D. Although the quadrilateral has the shape of a rectangle, we want to show that it is indeed a rectangle. So let's consider the vertex A has the coordinates -2, -4. B has the coordinates 4, 0. Vertex C has the coordinates 2, 3. And vertex D has the coordinates -4, -1. Now, in order to show that ABCD is indeed a rectangle, what we'll do, we'll show that the length of AB is going to be equals to the length of CD. And length of BC is going to be equals to the length of AD, because the opposite sides of a rectangle are of equal length. Also, we'll need to show that AB is parallel to CD and BC is parallel to AD. Furthermore, we will also have to show that the side AB is perpendicular to the side BC. Then BC is perpendicular to CD, CD is perpendicular to DA, and DA is perpendicular to AB. So when all these criterions are met, we can say that ABCD is going to be a rectangle. So let us begin by first finding out the length of the side AB. Now, in order to find out the length of side AB, we'll have to use the distance formula. So what we have to do is take the square root. Underneath the square root, first what we'll need is the difference of the x coordinate. Square it and add it to the difference of the y coordinate, and then we're going to square that value as well. So let's begin by first obtaining the difference of the x coordinate. So we will do b minus a. So we'll first take 4. And from here, we're going to subtract the x coordinate of a, which is -2. So negative of -2 makes it +2. So we have 4 plus 2 squared. Then we'll find out the difference of the y coordinate. So we have 0 minus -4. So that means we have +4 squared. So this is going to be equals to, so we have 4 plus 2, that's 6. Square of 6, that's going to be 36. Added to 4 squared, so that's going to be 16. So this is going to give us a value, square root of 52. Okay, now let's find out the value of the length of side CD. Again, we'll use the distance formula here. So we have the square root. Underneath the square root, we'll take the difference of the x coordinate. So we'll do -4 minus 2. So that's going to be -6 squared. Added to the difference of the y coordinate. So we have -1 minus 3. So that's -4 squared. So this is going to give us a length, square root of 52. So clearly we see that AB equals to CD. So the sides are of equal length. Similarly, we can show that BC equals to AD. So let's find out the length of BC. So BC will be equals to, we'll take the square root. Underneath the square root, we'll take the difference of the x coordinate. So that's 4 minus 2 squared, added to 0 minus 3 squared. So this will give us a value. We have square root of 4 minus 2 squared, that's 4, plus 3 squared, -3 squared, that's 9. So we're going to get 9 plus 4, that's 13. So we have square root of 13. We can also find out the length of side AD. So that will be equals to, we'll take the square root. We need the difference of the x coordinate. So -2 minus -4, that means we have -2 squared. Added to -4 minus -1, that means we have -4 plus 1, which is simply -3 squared. So this is also going to give us a value equals to square root of 13. So we have also showed that side BC is equals to the side AD. So let's call it number 1 and this is number 2. So from 1 and 2, we have showed that the opposite sides of the quadrilateral ABCD are equal. Now let's find out the slope of each of the side. So slope of AB. So to find out the slope of any side of a given line, we only need is the endpoint. So here we have the endpoints of A as endpoints A and B. So we'll take a ratio. In the numerator, we need the difference of the y coordinate. So we'll do 0 minus -4. And in the denominator, we need is the difference of the x coordinate. Since we started out with B, so we'll take 4, and from here we're going to subtract the x coordinate of a, so that's -2. So this is going to be equals to 4 over, so 4 minus -2, that's going to be 6. So slope of AB comes out to be 2 over 3. So let's obtain the slope of the side CD. So that's going to be equals to, we'll take the difference of the y coordinate divided by the difference of the x coordinate. So we'll do 2 minus -4. So this is going to be equals to 4 over 6. So this also gives us a value 2 over 3. So here we have shown that slope of AB equals to slope of CD. So slope of AB comes out to be equals to the slope of CD. So that tells us that the side AB is parallel to side CD. So this is condition number 3. Now we will find out the slope of the side BC and slope of side AD, and we'll show that they are also equal as well. So slope of side BC, so that's going to be equals to, we'll take the difference of the y coordinate 3 minus 0 divided by the difference of the x coordinate 2 minus 4. So that's going to be negative 3 over 2. Then we have the slope of side AD, so that's going to be equals to, we take negative 1 minus negative 4, that's the difference of the y coordinate, divided by the difference of the x coordinate, so that's negative 4 minus negative 2. So negative 1 minus negative 4, that's negative 1 plus 4 divided by negative 4 plus 2. So we get negative 1 plus 4, so that's positive 3. Negative 4 plus 2, that's negative 2, or simply we can say it's negative 3 over 2. So this here also tells us that slope of side BC equals to the slope of AD. And this only means that BC is going to be parallel to side AD. So let this be number 4. So we have showed that the opposite sides of the quadrilateral ABCD are parallel and they are of equal length. However, we are not still done yet, because ABCD could also be a parallelogram, because in a parallelogram the opposite sides are parallel and are of equal length. Now what we'll do, we'll take the slope of AB. We have already obtained the slope of AB, and we're going to multiply that value with the slope of side BC. So let's find it out. What's the slope of AB? So we obtained that the slope of AB, that's 2 over 3. So we have 2/3, and this will be multiplied to the slope of BC. BC is negative 3 over 2. So that means we have a value of negative 1. Since the product of the slope of two lines are negative 1, that means that the side AB must be perpendicular to the side BC. So similarly, I'll leave that as an exercise for you to try out. We can say that, let's write it down. Also, the side BC is going to be perpendicular to CD. CD will be perpendicular to DA, and DA will be perpendicular to AB. So all the criterions are met. Therefore, we can say thus ABCD are the vertices of a rectangle. Hence, we have successfully proved the given problem.